Today we're going to be talking about exponential and logarithmic equations and solving them. So now that you guys have worked with exponential and log functions, we're going to talk about what do you do when you're given an equation with a log or an exponential in it. And so here are some strategies for solving exponential equations with different bases. And some strategies for solving logarithmic equations. And so I'm going to give you, if you would like to pause it and read through it, you can do that. Otherwise, I'm just going to kind of let you read through that on your own, and then we'll be using these strategies throughout solving. So we're going to jump right into the examples, okay? So the first couple of examples are verification problems, which means, you know, are they solutions or are they not? So they are giving you values and asking you to plug them in and verify, is this a solution or is it not? And so the first one is 4 to the 2x minus 7 equals 64. So they give us the values x equals 5 and x equals 2. I'm going to plug those in. So 4 to the 2 times 5 minus 7 equals 64. So all I am doing is verifying. Does the left side equal the right side? So 2 times 5 is 10, minus 7 is 3. So what we have is we have 4 to the third equals 64. Now 4 times 4 times 4, or 4 to the third, is 64. And 64 equals 64. So we have verified that the x equals 5 works. We're going to do the same for 2. So 2 times 2 minus 7 equals 64. And so that's going to give us 4 to the negative third equals 64. Now, 4 to the negative third would be 4 times 4 times 4 is 64, but that negative means that it goes in the bottom. So what we have here is we have 1/64 equals 64. And that right there is not a true statement. And so what I'm going to come over here and say, and what I expect you to do on your homework, is to say x equals 5 is a solution. X equals 2 is not a solution. So what I'm going to need to see on your homework is you showing your work, like I did here, showing the process for all of them, whatever numbers they give you, and then make sure that you indicate which ones are solutions and which ones are not. So we're going to do it again, this time with a log, not an exponential. So log base 4 of 3 times 21.3560 equals 3. So what you'll need to do here is in your calculator, you will want to make sure that you use the log base log. And so when you plug all of that in, you get, it's like 2.999, which rounding wise, we can go ahead and say, you know, 3 equals 3. That one works. And so we're going to do the same for x equals negative 4. So log base 4 of 3 times negative 4 is 3. So what you will want to type into your calculator is log base 4 of negative 12 equals 3. And that one does not work. And so if you notice a pattern here, when we plug in our x value and we get negative values, negative exponents or negative logs, that is where we're finding that we have no solutions. So I'm going to come over here and say x approximately 21.3560 is a solution, and x equals negative 4 is not a solution. And that's going to be my final answer. So on these first two and on the first several of your homework, that's all you're doing is verifying. Are these solutions or are they not? Now we're going to move on to solving exponential equations. And it says give the answer in exact form. Okay, exact form is going to be no decimals. We're going to leave it in the purest form that we can. First thing you want to do when you solve exponential equations is look and see, is this one where you could make the two bases become the same number? And if it is, then that's the way that you want to approach it. If it's not, then we'll approach it a different way. But you always want to check and make sure with exponentials that, because if you can make the bases be the same, that's what you want to do. So if you notice here, we've got 4 and we've got 16. We can turn those both into base 2. So that's what I'm going to do. 4 is 2 squared. And 16 is 2 to the 4th. And so when you clean this up, you multiply these together. So that's going to give me 2 to the 2x equals 2 to the 4th. And now, because your bases are the same, all we have to do is set the exponents equal to each other. So 2x equals 4, and then solve. Divide by 2, x equals 2. So that's where it's pretty simple. If you can make your bases become the same thing on the left-hand side and on the right-hand side, then you just set the exponents equal to each other and solve. Let's look at part B. Same thing. Look and see. Can you make the bases become the same number? So you have 8 and you have 64. Now we know that we can change 64 into a base of 8 because that's going to be 8 squared. Now, as far as 1/8 goes, all we have to do is move the 8 up and make it negative. And then combine, so 8 to the negative 1x equals 8 squared. Your bases are the same, so all you have to do now is just set your exponents equal to each other and solve. X equals negative 2. And there you have it. So those are examples of when you can make your bases become the same number on the left side and on the right side. Now we're going to move on. Part C is where we're going to deal with solving exponential equations where you cannot make the bases become the same number. So look at part C. The first thing you always want to do is you want to isolate the exponential. Okay, so how we're going to start this is I'm going to isolate my exponential by dividing out the 6. So divide by 6, 10 to the x equals 36. Now, I can never make the base of 10 and the base of 36 come down to the same number. So in the event that you cannot make your two bases become the same number so that you can set the exponents equal to each other, you're going to have to take the log of both sides in order to use our exponent rule where we can drop the exponent down and solve. So I'm going to take the log of both sides. So log of 10 to the x equals log of 36. And then from here, what I'm going to do is I am going to use my log rules and drop that x down in front. So it's going to look like this. X log of 10 equals the log of 36. Now, remember our other rule where we have, if your two bases are the same, then your exponent is your solution. So this actually will all go to 1. So what I've got is x times 1 equals the log of 36. So x equals the log of 36. Now, because it tells us to leave our answer in exact form, I am not going to plug that into my calculator and get a solution. I'm going to leave my answer as that. Now, if I were to plug that in and approximate the solution, I would get 1.56. Okay, but if it tells you leave it in exact form and you take it further to a decimal, you're going to lose some points. So make sure you pay attention to what the directions are saying, whether it wants you to leave it as exact or whether it would like for you to round. Now, on to the next one. We have 2 natural logs. So what we have to do is use our log rules and combine that to make it 1. When I do that, remember the minus sign, I can compress this into 1 by dividing. So that's exactly what I'm going to do. I'm going to write it as 1 log, natural log, and then of x divided by 5 equals 0. So now that I have it as 1 natural log, I can change this into exponential form. So that's what you want to do when you are dealing with solving equations where they have logs or natural logs in them, is you want to get it down to where you have 1 single log. And then you want to change it into an exponential. So remember, the base of a natural log is e. So I'm going to do e to the 0 power equals x over 5. Now, anything to the 0 power is 1. So this is what I have. And now I'm just going to use cross multiply and divide. So x equals 5. And that's my solution. Okay, so on part E, we're going to do the same thing. First, you want to make sure you have 1 single log, which we do here, and then you change it to exponential. So this is going to say x to the 4th equals 625. Now, what do I do to solve for x? It's raised to the 4th power, so I'm going to need to undo that 4th power by taking the 4th root to cancel it out. So what you do to one side, you do to the other. So we're actually going to take the 4th root of 625, and that is going to give me the answer of 5. Now, normally, whenever you take an even root, so the square root or the 4th root or the 6th root of something, remember you have to include a plus or a minus because you don't know which it was. And so don't forget that technically it's a plus or minus 5, but because we can't take the log of a negative number, we're going to actually just disregard the fact that we have a negative there. Okay, and only take the positive answer. Okay, so example 3 says simplify the expression. So what we're going to do is we're basically just going to use those log rules and our exponential rules that we had from last time, and we're going to use that just to simplify this expression down. So if you look here on part A, I know I can use my log rules to drop that x squared down in front. So that's exactly how I'm going to start my problem. I'm going to drop it down in front, and that's going to leave me with the ln of e. Now remember, when your bases are the same, this goes to 1, or whatever the exponent would be. In this case, our exponent was 1, so that's going to go to 1. So we have x squared is our final simplified expression. On part B, we're going to do the same thing. I am going to take my exponent here, 2x, and I'm going to drop it down in front using those log rules. Okay, and when I do that, again, this will go to 1. So I'm going to write my answer as 1 plus 2x times 1, which 2x times 1 is just 2x, and that is my simplified expression. So when you see your problems just like that, just know you're using those log rules that you learned last time to just help you simplify it down. Now we're going to get to some more exponential equations. This time, instead of an exact form, if you read the directions, it says round to 3 decimal places. So on these problems, I am going to actually calculate it out. So I will calculate it out and round to 3 decimal places. Same thing, same rule. Always check and see, is there a way that you can make your bases become the same? And the answer here is no. So if the answer is no, then what you do is you just go ahead and you start by taking the log of both sides. So log of 8 to the 3x equals log of the 360. And then the purpose of you doing that is so you can drop that down in front, and he's no longer in the exponent anymore, and then you'll be able to solve for x. So I'm going to drop that 3x down front. And I've got log of 8 equals log of 360. Now, what you want to do is you want to go ahead and you want to divide out log 8. Log 8 is just a number. So we're going to go ahead and divide both sides by log of 8. So in your calculator, you'll want to make sure you get your calculator out and do log of 360 divided by the log of 8. And you can go ahead and round to 3 decimal places there. So what I've got left is I've got that 3x equals, when you do log of 360 divided by log of 8, you get 2.831. And then you're going to just finally divide the 3. So divide both sides by 3, and you get approximately 0.944 as your solution. Okay, so on part B, remember the first step you want to take is you want to isolate as much as you can the exponential part. So if you're looking here, I want to isolate e to the negative x. So what I'm going to do is I'm going to divide out that 500. So I'm going to go ahead and start by dividing both sides by 500 to isolate my exponential. So I've got e to the negative x equals 0.6. Now, from here, you're going to have to take the log of both sides in order for you to drop that exponent down in front to solve. Now, if I have a base of e, I'm not going to take a regular log, I'm going to take a natural log. So I'm going to do ln of 0.6. So you always just default to log unless it's got an e base on it, and then you use a natural log. And then what I'm going to do from here is drop down that negative x in front using my log rules. So I'm going to have negative x ln of e equals ln of 0.6. And then remember, this will go to 1. So then I've just got negative x equals ln of 0.6. Divide by negative 1 to cancel that negative out. And you get approximately ln of 0.6 divided by negative 1 is about 0.511. And that will be your solution. On part C, again, you always want to start when you're solving an exponential by isolating the exponential. So my goal is that I'm going to get 2 to the 3 minus x by itself. So you would work that just like as if you are working an equation. So how do you get that by itself? Well, first we're going to start by adding 13 to both sides. So we're going to have 5 times 2 to the 3 minus x equals 113. And now I'm going to divide by 5. So divide both sides by 5. And now I have the exponential all by itself. 113 divided by 5 is 22.6. So now I'm to the point where I'm going to actually take the log of both sides. So I'm going to take the log of both sides. So log of 2 to the 3 minus x equals log of 22.6. And same thing, once I reach this point, once I have taken the log of both sides, you drop the exponent down in front. So I'm going to have 3 minus x times the log of 2 equals the log of 22.6. I'm probably going to go put parentheses around that. Okay, so remember your goal is you're solving for x. So think about this. I'm going to need to divide out my log of 2. So I'm going to divide both sides by log of 2, and I'm going to go ahead and round to 3 decimal places. So what I've got is I've got 3 minus x equals 4.498. My next step to solve for x is subtract 3. So I've got negative x equals 1.498. And then finally divide out that negative. So x equals negative 1.498. And that's the solution. Okay, on part D. If you will look at that, you can kind of tell it's kind of unique. This is going to actually be similar to like when you factor a quadratic. So what I'm going to do is I'm going to just use some substitution so that it doesn't get confusing. So basically what I'm going to do is I'm going to say, okay, I'm going to use u, I'm going to let e of x be u. So what I've got is if I rewrite my problem using u instead of e to the x, I've got u squared minus 4u minus 5 equals 0. And now you can kind of tell, it's a little bit easier to tell, that's a factoring problem. I'm going to go ahead and factor that. So u, and you're breaking down the factors of 5 that subtract to negative 4. That's going to be negative 5 and positive 1 equals 0. So at this point, now what I'm going to do is I'm going to split these up, and I'm going to go ahead and plug in e to the x. Plug that back in for u. So what I've really got is I've got e to the x minus 5 equals 0. And I've got e to the x plus 1 equals 0. So I've got like 2 little equations I'm going to solve. So then what you're going to do is you're going to isolate the e to the x equals 5 and isolate it over here, the exponential. Now what we're going to do is we're going to take the natural log of both sides. So this is going to be ln of e to the x equals ln of 5. And this is going to be ln e to the x equals ln negative 1. Now, again, we're going to use that log rule to drop our x down in front on both. So what it's going to say is x ln e equals ln of 5. So to solve this, remember ln of e goes to 1. So what we have is we have x equals ln of 5. And so when you plug that into your calculator, you get 1.609. And now we're going to do the same for the other one. So what I've got is I've got x equals, or x ln of e equals ln of negative 1. So this goes to 1. So then what we have is we have x equals ln of negative 1. And when I plug in ln of negative 1 into your calculator, when you do that, you will see that it will give you an error, non-real answer. We can never take the log of a negative number. So this one is going to be no solution. We do have one solution though, so I'm going to go ahead and box that one in. So our only answer here is 1.609. Now on to solving log equations algebraically, and we're going to round to 3 decimal places. So they don't want exact, they just want us to go ahead and plug them into the calculator and calculate the answer. Okay, so first things first, you have to get everything to one side. So I'm going to go ahead and I'm going to move this log, I'm going to move it over here by subtracting it. So I've got log base 5 of 3x plus 2 minus log base 5 of 6 minus x equals 0. Now, because both of these logs have a base of 5, they're the same base, we can go ahead and combine this, compress it, like you did in your previous lesson. And so remember, that minus sign means that I'm dividing. So when I write this as one log, I've got log base 5 of 3x plus 2 divided by 6 minus x equals 0. So what I've done is I've gone ahead and compressed it down to where I only have a single log, one log. Now what I'm going to do to solve this for x is I'm going to change this from a log form to an exponential form. So I'm going to say 5 to the 0 equals 3x plus 2 over 6 minus x. And then solve that out. Now, remember, anything to the 0 power is 1. So 1 equals 3x plus 2 over 6 minus x. And then use cross multiply. So this is going to be 6 minus x equals 3x plus 2. And go ahead and solve for x that way. So I'm going to get my x's to one side and my numbers to the other. Add x. So that's going to be 4x, and then minus 2 equals 4. Divide by 4, and we get x equals 1. And there's our solution. We're going to do that on part B as well. Now notice we have a single log, so we've already got it down to where we have a single log. It's just a matter of isolating the log. So I'm going to start by dividing by 7. So what I've got is I've got log base 4 of 0.6x equals, now 12 divided by 7 is a repeating decimal, and so I'm going to actually just leave it as 12 over 7 throughout my problem so that I have a more exact answer when I get to the end. That leaves no room for rounding error. So now what I'm going to do is I'm going to change this to exponential form so that I can solve for x. So 4 to the 12 sevenths equals 0.6x. And then I'm going to divide both sides by 0.6. So then in your calculator, you can do 4 raised to the 12/7 power divided by 0.6. And you get approximately x to equal 17.945. And that will be my answer. On part C, if you notice, there's 3 different natural logs. So what I'm going to do is I'm going to move everything to one side so that I can combine it down to one log. So I'm going to go ahead and I'm just going to move this one over. I'd rather move one thing than 2. So I'm just going to move everything on the left side to the right side. So I've got 0 equals ln of x minus 1 minus ln of x plus 1 minus ln of x plus 5. And now what I'm going to do is I'm going to write that as one log. So I've got 0 equals. Now, what we're going to do is everything that has a negative in front of it, so this one and this one, means that it is going to go to the bottom. So I'm going to write it as ln of x minus 1 over x plus 1 times x plus 5. And set it up that way. And then, of course, the last step is I've got it down to a single log. Now I'm going to change it to exponential so that I can solve for x. So remember, the base of a natural log is e. So I've got e to the 0 equals x minus 1 over x plus 1 times x plus 5. And now what I'm going to do, e to the 0 is 1. And I am going to cross multiply. So 1 times that. So I've got x plus 1 times x plus 5 equals x minus 1. Now on the left side, what I've got is I've got to FOIL that together. So I'm going to come over here. I'm going to write x squared plus x plus 5x plus 5 equals x minus 1. And so now what I'm going to do is I'm going to move everything to one side. So minus x and plus 1. And I've got x squared plus 5x plus 6 equals 0. That's a factoring problem. Break down the factors of 6 that add to 5. That's going to be 3 and 2. So we've got x equals negative 3 and x equals negative 2. Now, if you'll remember, if you get negative solutions, we have to cross them off. We can't have negative answers. So both of my solutions here are negative. And that's a problem because I can't have either one of them. So your actual final answer here to this problem is no solution. Or you can write the 0 with a line through it. Because both of the answers that I got were negative. So I can't have either of those. Now, we're going to take a continuous compound problem and we're going to put a twist to it now that we know how to solve these equations. And remember the formula, A equals P e to the r times t. Okay, so now we have deposited $500, so that is your principal amount. So $500 is going to be what goes in for P. And then we have our rate is 6.75%. So we've got 0.0675. Okay. And T is going to be what we're looking for. We want to know how long. So we're wanting to know the time frame. How long will it take for you to double your money? Now, if I start off with $500 and I'm wanting to double that, what is that going to give me in the end? That's going to give me $1,000. So this is my equation that I have set up. All I'm going to do now is solve for T. So your goal is solve for T, just like if we solved for X in any of our other problems. So the first thing you want to do is you want to isolate the exponential. So I'm going to go ahead and divide out 500. Divide out 500. So that's going to leave me with 2 equals e to the 0.0675t. And now I'm going to go ahead and take the natural log of both sides. So I've got ln of 2 equals ln of e to the 0.0675t. And now, using my log rules, I can drop that down in front. So I've got ln of 2 equals 0.0675t ln of e. Now remember, ln of e goes to 1. So now what I've got is I've got ln of 2 equals 0.0675t. Divide out the 0.0675, and that's going to give us t. Now when you plug all of that into your calculator, ln of 2 divided by 0.0675, you get about 10.27 years. So we will have doubled our money in about 10 years. Now the next question says, how long will it take your money to triple? So what I'm going to do is I'm going to leave this to you. You're going to do the same process. You're going to solve the same equation. The only difference is going to be that this amount right here, instead of being 1,000, is going to be 1,500. So you're going to use 1,500 right here, but your equation is going to be set up exactly the same. And I'm going to let you follow that and see if you can do that on your own. Now, I'm going to go ahead and tell you that the answer, so this is for double, and then for triple, you're going to get about 16.28 years. So go ahead and try solving that out and see if you can get the same answer. And that takes care of solving exponential and log equations.